Good evening, everybody who's listening live, and of course, the people that will be watching this over and over and over again on the First Canada YouTube channel after we have put the recording up there. Today, we're actually having a special guest. As you can see from the screen, it's Craig Maynard, who is first senior mentor. Although when you see his picture, you're going to say, my God, he looks so much younger than the first senior mentor that runs this webinar. And Craig is actually in Calgary, Alberta, where he lives. And there you can see him. As he pointed out to me, he's the one on the left. He's got a little bit of a resume there. And as you can see from his email at the bottom, he obviously is interested in having people contact him if he has any question, if anybody has any questions. So Craig is a first senior mentor. He is a co-founder of First West, which is the Alberta group that runs First Out West. They have First Lego League Junior, First Lego League, FTC, First Tech Challenge, and FRC. So they have the full spectrum of 4 programs in First, and their teams compete in the World Championships in Houston. So if you ever get a chance to go to that one, you'll enjoy that one. You might meet up with Craig and some of the other Alberta and BC people when you're down there. And he has a passion for invention and design. He has all sorts of interesting things that he has done over his time at SAIT and in First. Just to update you, this is the last of the webinars before Christmas, for the kickoff, I guess we could put it that way. So we're looking forward to that. Obviously, everybody's excited about the FRC kickoff on January the 5th and all the kickoff events. I'm actually going to post another one of these that I'm just going to do it on my own with some information about kickoffs that I'll post into the same place, and I'll post the link to the recording, as I will with this one, on the First Canada Facebook page, so you can see it there. And so, as I said before, please feel free to ask any questions that you might have. So today, Craig is going to talk to us a little bit about Solidworks, which, if you are a rookie team and you don't know this, it's already available for you for free for the students on your team. If you go into your dashboard and you go to the product section, passwords and product vouchers, you will see that there's a link there for the virtual kit of parts and some of the software packages that you can download for free for your students. And one of them is SolidWorks. And without much further ado, here we go. You're on this platform now, Craig. So.
All right, Paul. So you can have more ado if you want to. We have lots of time for ado. There was a lot of stuff, that we can talk about with First Robotics. But one of the things that I've always really enjoyed in my career in automation and mechatronics and those guys is the art of simulation. Guys, I found very quickly that almost everything that I work with is either too expensive or too big, too heavy to move into the house, or I haven't got enough of them for everybody to share. But of course, with simulation nowadays, it's been possible to have virtual representations of everything in people's hands directly. And so I've always enjoyed simulations, all the Festo simulations they have, Robot Studio for simulating robotic arms and things like that. I used to love Second Life quite a bit for simulating sort of a simulated social network thing. But I've always had a passion for SolidWorks. SolidWorks is an amazing product. And so I volunteered with Paul, or I asked if I could give a little talk about SolidWorks. Now, of course, I would love to be able to give you a training course on SolidWorks itself, but SolidWorks is huge. It's gigantically, enormously huge with a whole bunch of facets. I used to teach at SAIT 2 15-week semesters, 6 hours per week. That's 90 hours of non-stop SolidWorks, and we moved like a bat out of heck, and we still couldn't cover all the stuff that SolidWorks does. It's just an amazing program, and that's just the basic SolidWorks. There's also SolidWorks for printed circuit boards, and SolidWorks for fluids, and SolidWorks, just you name it. SolidWorks has reached into so many elements of engineering. But because it is so popular, it's also a very, very powerful thing for us to learn. It's going to be great on your resume. It's going to be great when you go out there looking for jobs, but it's also an incredible resource in FIRST Robotics because of all the opportunities you have is in solid modeling. So, of course, I use SolidWorks not just for education, but to make mechanical elements I use. For instance, if I have to design something in my virtual robotic work cell, I'll make all the jigs out of SolidWorks, and I import them into the work cell, and the robot will work on those before I ever have to bring the thing up in real life. I can set up the entire robot simulations. Now, the cool thing about SolidWorks, as Paul already alluded to, is SolidWorks supports FIRST in a big way, and SolidWorks itself is part of the kit of parts. So I'm going to show you guys basically how to learn SolidWorks, maybe give you a suggested roadway, but there is no way that I could teach you all the fundamentals of this application. But the one thing I do have to tell you about SolidWorks is it's kind of like walking into a Las Vegas buffet, when you can learn, you can go to a buffet and it's got so much food, and you end up filling up a plate full of garbage, 300 kinds of meats and 2 desserts and not what you would call a balanced, well thought out, structured meal. And part of the joys of going to a restaurant is when you get fed there, you get fed correctly. You get fed in the correct order. You get your appetizers and your food, and the food's properly laid out, and it's well delivered. And then you get your dessert, and everything sort of works. You go to a buffet, you pig out. SolidWorks education is a lot like that. There is so much information out there, you don't know where to start. So let's have a look at some ways we can get started, and I'll give you a suggested path. So how are you going to learn SolidWorks? Well, as we already talked about, the SolidWorks is available in the entire kit of parts, or in the kit of parts. So you can get the actual program itself. You can download the code and run SolidWorks directly on your computer. And there is also a simulated SolidWorks. There is an online version of SolidWorks where you can do a lot of your work on any computer that has a web browser. So basically, it looks like SolidWorks, but you run it inside a browser, and you don't have to have a red hot, powerful computer in order to operate it. That's kind of neat. That means you don't have to have every one of your systems SolidWorks compliant, because the SolidWorks does need a pretty fancy graphics card and quite a high-end processor and a lot of memories. But these virtual packages, this virtual SolidWorks you can get that you open up on a web page wouldn't need all those things. A Chromebook could do it. So SolidWorks is available in your kit of parts, so you could download it or you could use the online version. SolidWorks is also available in the entire kit of parts, I'm going to say, is also available in SolidWorks files. So if you go to this YouTube video right here, that's nothing to do with Sweden. That's actually SolidWorks Education. That's the group that runs it. There's a whole video right here which will tell you how to download those kit of parts. Every motor, every bracket, every pneumatic element, it's all modeled in SolidWorks, and you can import it into your program. Not only that, this year they're actually releasing the field in SolidWorks as a simulation. So if you go down to this link right here, for instance, I'll just bring it up for a second. There we go. So the field itself, the playing field, can be now witnessed through your video on your computer, on your mobile device, with a VR headset, with your own scale model in 2 dimensions. It's even got a little version you can print out on a 3D printer. So so that you can actually see what the new field is going to look like during this year's kickoff directly as a virtual model, which is very cool. So there's another example of virtuality. And this is a little YouTube video right here that describes the field for you. There you can see it right there. Of course, you can. It's a great way to visualize point of views and angles of attack and things like that. And every element in this field is a separate SolidWorks assembly. Now, I don't know if it was actually SolidWorks that you used to create this, but it sure could have been.
Wow, that's pretty impressive.
Isn't that something?
Yeah.
No, why? All right. just so you don't have to listen to why Chinese manufacturing wins right now. We'll just cut that down. Book. Yeah, so yes, of course, SolidWorks is a major sponsor for FIRST. Okay, where was I? Now, there's a lot of sources for tutorials or education in SolidWorks. Right at the bottom here, this I'm gonna relate this to food again because we are in Christmas time and food is top of our mind. I would consider the best service and the best kind of education you can get as always being in-class training. You know, it's just like having a waiter or maitre d' come and help you through your supper and give you the whole wonderful experience. So books and training, obviously the best. I've got I'd say about 8 inches of books here. I've been trained in SolidWorks. I got my certification through something called Hawkridge Systems. I believe they're in the Eastern Canada as well. They're all across the states. Hawkridge Systems does nothing but SolidWorks training. So if you can afford to have those guys come and talk to your team, that'd be fantastic. There's a lot of SolidWorks tutorials that are out there as well. The SolidWorks tutorials are everywhere, but they're all out of sequence. And worse yet, a lot of them teach you bad habits. And it's easy to get into one of these monster packages and lock yourself into a set of behaviors that would really bite you later on. It makes you, you learn bad things, you lock them into your psyche, and then you have a hard time unlearning them. So it's always best with these kind of programs to learn how to do it correctly from the beginning and then keep going that way. The other thing about SolidWorks too is, especially with online tutorials, the SolidWorks updates every year, sometimes more frequently. Although a lot of the principles from the older tutorials are still valid, after 3 or 4 or 5 years, some of the links get kind of stale, and you don't know how those education tutorials actually align with SolidWorks 2018. So lots of sources we're going to look at. First Inspires has got some great sources on SolidWorks. You can actually go to the SolidWorks website itself. YouTube's got a bunch. A lot of teams have done some amazing stuff on SolidWorks education. I found a couple I brought up. Corporate resources, a lot of companies out there like Hawkridge also teach you how to do SolidWorks. So there's lots and lots of these elements, and we'll look at those in a couple minutes. But let's have a look at the stuff you can do with SolidWorks. SolidWorks, the basic package itself has got a lot of features in it that are going to make it very useful. You can design your entire robot before you even bolt the two things together. And I know a lot of good teams will do that. They actually create their entire robot totally electronically in SolidWorks. They bring all the assemblies together. They attach all the bits and pieces and screws and bushings and bearings, the battery, the motors, everything, all as a solid model. They make sure there's no collisions. They make sure it's going to work well with all the parts and pieces, that the end effectors work well, the articulators work well, drive system works well. And then with about 3 weeks to go until the bag and tag day, they send out all the parts to the machinists, or they machine what they can themselves. They bring it back together, they bolt it together, and 90% of it works right out of the box. So it's a really good idea to do solid modeling first, and even well before the competition's released. Solid modeling, of course, you'll start with solid modeling with parts and assemblies. You can also do simulations in SolidWorks. So simulations, we can take a part. Have you noticed some parts break on your robots? You got that bracket or a doohickey or a thingamabob that's hooked onto a motor and it snaps for whatever reason. Well, if you did simulations on that and estimated the forces, you probably would have seen where the weak spots are, and you could have probably redesigned that. Or maybe you're over designing things, making them too strong, too heavy, unnecessarily robust. So simulation tools are there. Weldment tools are there, so you can actually take a shape like this little structure right here, draw it as single lines, just as single lines, and then tell it I want that made out of C-channel or box channel or whatever, and it will create it for you, and it'll even set it up so you can weld it. And then it gives you a cut list. Each individual part is ready for you to cut, so it'll do weldments. That's something very, very powerful in SolidWorks. You can do sheet metal tools. There's a lot of very strong elements in your robot you can make out of simple sheet metal. Sheet metal is wobbly and flimsy by itself, but you bend it and shape it and curve it, it becomes very, very strong. So sheet metal tools are another powerful tool available in SolidWorks. Of course, you can do molds and shells. You can create ribs and things like that in SolidWorks, which is great if you're doing 3D modeling, 3D printing. It'll create a bill of materials, which you can use for sending out and getting all your parts created. It'll do the two-dimensional drawings for you to send out to your engineers. The thing will even do environmental studies. So it'll tell you that your robot itself uses a lot of parts that are made in too far away, takes the carbon footprint of using this robot is very high. Maybe you should go more toward these kind of metals and these kind of products to get your carbon footprint down. Now, we don't get a lot of points in FIRST Robotics for how much of a carbon footprint our robot creates on the environment, but SolidWorks will tell you just how bad it is. So all of those elements are there, and that's just in the basic package. Now, let me look at some of the SolidWorks tutorials right now. The ones that leap to mind right off the bat are the ones that exist in SolidWorks itself. So if you actually bring up SolidWorks, let's see if I can find it here someplace. Oh, look, there it is. There you can see SolidWorks up on your screen. And if you go to search SolidWorks help, you can search for any help you want. Or you can click on the question mark. Oops. Let me get that back there. You can click on the question mark, and there are SolidWorks tutorials. You click on SolidWorks tutorials, and they come up on another screen. Sorry about that. Here they are. So there's all your getting started tutorials, your basic techniques tutorials, advanced techniques. Now, I find some of these tutorials, they move pretty fast and get you to the danger zone, the deep end of the pool, a little faster than you might want. But they're a pretty good start, though. So there's those SolidWorks tutorials. I really like this one. Here's student curriculum. So if you look in student curriculum under SolidWorks and you click on that, you'll actually see something that says FIRST right there. There's blocks, robotics, there's routing, SolidWorks curriculum. You can see it right there, curriculum 2016, if you want to go there. And it'll take you all through it that way if you want. But let's get back to the good stuff, robotics. And there's the first robot. And if you download this, control and click on it, it actually will bring up the kit of parts for FIRST Robotics, and that's right in SolidWorks. So that's a great testimonial. Yeah. So right from SolidWorks, you can actually get to it. And as I said before, you don't have to have the actual program itself. There is a virtual version of SolidWorks. So if you go to my.solidworks.com, click on that. That website is another SolidWorks supported thing for training and CAD models and all this documentation's over here. So you can get all the training and stuff you want through my SolidWorks. And here's a section on learning paths, which is probably sort of what I'm trying to talk about right now. Gives you a learning path for your SolidWorks education. Okay, now outside SolidWorks, there's the YouTube videos. So if you go to YouTube, I should have probably given these the titles here. Just bring this up right here. Here's a YouTube channel devoted to SolidWorks, all SolidWorks tutorials with dramatic music. All right, I like the music. And the YouTube videos, here's another one right here, which I also really enjoyed. It's from a company that you can see a whole bunch of videos right here, and I can't remember which. Oh, this was a SolidWorks beginner tutorial section, so you can see the tutorials actually are sequenced. Tutorial 1, 2, 3, 4, 5, 6, 7, and they're not bad. They're a little old, they're 2014, but as I said, the basic fundamentals are all the same. So I really do encourage you following a nice sequence set like this. So that's the YouTube videos. Down in First West, we've got a whole bunch of videos too. We had a little webcast we tried last year as well. And there was a SolidWorks right here. There's a spooky SolidWorks for beginners. We started right there. But if you wanted to add all this stuff onto your information, if you'd like to learn about FIRST Robotics, there's all those things as well. And that's from our site. Symbotics has got a real awesome SolidWorks series. There's actually a few great pages out there, but Symbotics has got a series, takes you from the introduction, how to get SolidWorks, uses and applications, what the menus are, the templates, all the way down to some very advanced features.
I like how they're, you can see all the timings are nice and short. Maybe it's me at my advanced years and short attention span, but I like that aspect of it.
It's bite-sized, isn't it?
Yeah, yeah.
You know, I walk into some of these 35 or 1 hour long websites, and it makes you cringe.
Yes, exactly.
Yeah, but if it's from Symbotics, you know it's good too, because those guys are always contenders.
Yeah.
All right, so that's Symbotics. Those are a few great educational resources out there, and I'm sure that you can probably find more. But make sure that you do check the comments, because as I say, there's a lot of sloppy technique that people will, they pick up a program and they figure they can create something on the screen, but they do it with such a haphazard fashion. They come across as professional, but you're not learning good habits. So check the comments out, check the ratings to make sure they're pretty good. So I just wanted to talk to you a little bit about the sequence of education when you do find a good website for SolidWorks. The very first thing you really have to understand in the SolidWorks is everything on the desktop: the menu bar, command manager, feature manager, the heads-up toolbar, task pane, planes, all that kind of stuff. So when you look at SolidWorks, as we got right here, here we go. You can see we've got the menu bars up at the top. we've got all of these different windows that you have to learn about. I'm not going to go into any detail on them, but every one of them is very, very important and has a special function. You should learn those all in sequence. So the very first thing you want to have in any solid modeling application is the user interface. Next thing, now we're assuming we've actually got the user interface mastered at this time, and I'm going to leave you to find all those tools. The next thing you want to learn about in an application like SolidWorks is how you actually navigate around the drawing itself. So if you look at an object on the screen, we'll just draw a simple one. Lights here. Let's say we'll just do a simple sketch. And we'll go on the front plane here. We'll draw, I don't like boxes. We'll draw a box. Is this going to work for me? Draw on the front plane, and we'll draw a box on the front plane. And we'll take this and we'll extrude that out. Oh, I don't know. Maybe 3 inches. There we go. And we say, yeah, I like that. Here's a simple little box. So the person has to know how to be able to rotate this thing around. He has to know how to view it in different styles with edges. Maybe if you want to get rid of the shading entirely, you should know how this box works so you can see it from any angle you want. All right. So that's what I'm saying about and you should know how to look at your front planes, your different planes, keep them turned on. All that sort of stuff. So basically, we're talking about how mouse can be used, how to hide and show options, how to go into section view and things like that. Yeah, the section view they're talking about, I guess, is this thing right here where you can take this box and slide the section in and out to get a cross section of whatever it is we're looking at. That's the section view. But, again, I'm not trying to teach this. I'm just trying to show you the order. So once you've managed to master how to look at your object from any angle and view, Next thing you want to know about is your basic sketch tools. Now the sketch tools, SolidWorks always starts in 2 dimensions. So we always start on a plane, 2-dimensional plane, and it's a parametric modeling package. So everything is based on the parameters for that plane. We take that, but we start off as a 2-dimensional sketch, and the sketch can take from a line or rectangles or circles or those kind of things. You should talk about how to select units, all that kind of stuff. So by selecting the sketches, there we go. Get rid of all that. So when we started to sketching again, these are all the sketch tools: how to draw lines, circle, spline, a corner rectangle, an arc, ellipse, slots, all of those sketches, all right? And you should know all about those sketches, how to dimension the sketches as well, how everything should be properly dimensioned. So just for fun, I'm going to take this box I did right here. I'm going to nuke it because I don't love it anymore. I'm going to go to the right plane, and I'm just going to create a new sketch on that right plane. Right click on it. I'm going to go normal 2. Where am I here? Right plane. Normal 2. There we go. So now when I do my sketches here, we can create those. And with those, once we do the sketches, we can actually dimension them. I'm going to leave that the way it is. I'll make that 5 inches. Fine. I'll make this one 6 inches. Fine. Now, one of the most important things you have to do as a good SolidWorks modeler is pay attention to this little text right down here on the lower right corner. It says underdefined. Now, what underdefined means is that this thing, even though it knows this square is 5 inches across and 6 inches up and down, it doesn't know where it is in space. It has no idea. So if I was to, grab this sketch and move it around, right, you can say I can move it up and down backwards. There's nothing stopping me, or I could move it left and right, and there's nothing stopping me moving it there. Because compared to the origin, which is right over here, it doesn't know how it exists. So if I was to take this point right here and drag it up and lock it to the origin, now you notice it's fully defined. You notice the lines have all become black. That means I can't drag this thing anymore. It's absolutely defined in space and time. You know exactly what it is, a fully defined sketch. So that's what we strive for in SolidWorks all the time, is to create these fully defined sketches. So you also have to make sure you selected the right units. Right now, we're selected inches, pounds, seconds. Don't go like into your drawing and make about 2 hours worth of work and then discover that you meant to be in metric, but now you're in inches, because it's a pain to convert it back. Make sure one of the first things you do when you create a model is to choose the proper units. All right, so I would go next to the basic sketch tools. Once you do the sketch tools, we want to be able to make a 3D model out of those, using things called extrudes or bosses or a revolve or a sweep or a loft, those kind of things. So that's probably the next element you'll learn when you're doing solid modeling, or extrude cuts, bosses, revolves, and sweeps. So extrude, of course, if you go to features, there you can see the extrude. You can see I can extrude this thing to any length I want, right? Like that. Or I could take my extrusion. I'm just going to delete that extrusion. I don't want to extrude it. Cut, 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 cut. Delete that. Yes. Bring it back to a sketch. I could do something called revolve. Let me just go to sketch right here, and just for giggles, I'm going to do an imaginary center line on that plane. And I'm going to draw a center line from here to here. I think that's what I want to do. Hope this is going to work. Now I should be able to do a revolve, and we're going to choose the plane. We're going to choose the object we're going to revolve, and we can revolve it around the center line. And you can see we've actually taken that square now and revolved it into a cylinder. I haven't actually revolved it around the center line. Let me see if I can do that there. Now I've taken it and I revolved it around the center line that I've just drawn. So you can see you've got a wonderful looking donut, right? Anyways, that's revolving. You can, sweeping and lofting and those kind of things are other ways of making 3D objects. You have to learn how to do those. You can also do cuts too. You can do an extruded cut. For instance, I can go on this plane right here, and let me just do a sketch on it. Yeah, edit the sketch, and I'll draw a square right there. Am I doing it wrong? Okay, start over again. Discard that sketch. So if I click on this and I want to go edit the sketch, there we go, and sketch on it. Yeah, I'm not even going to go any further than this because it's not going to behave with me. I'm not going to behave with it. So you can do extrude cuts and bosses and revolves as well, which means instead of producing matter, you're taking matter away. You're actually cutting it out. So using these things, you can create 99% of the parts that you need to have in your object. Now, once the part is created, and you have a number of parts, you can put them together to create what's called an assembly. So the next thing you should learn is assemblies, how to bring on all the parts to create an assembly, how to mate these parts together, how to set up the origins and things for the parts so they can actually move freely, and all those things. You want to get into assemblies next. And from assemblies, once you get the part the way you want to have it, you should learn how to create drawings. So in drawings, you can create any part that you've designed and create a drawing for it.
And that would be great to have in your pit when judges come around to see how you've engineered what you've done. I mean, that would be very impressive to have a book of sketches and drawings, correct?
Absolutely. No, the better your engineering notebook is, the better it's going to be. All right. So now, one thing I told you about, mentioned about SolidWorks is it is it's a very computer-intensive application, and to demonstrate that, it actually crashed my program. Crashed my computer. So I'm going to have to start over again. Can you see my slide now?
Yep.
Is it back up? Okay. All right. So there's extruding, creating an assembly, create a drawing. That's an important thing. And then move on from there. So this is about all I can cover in about half an hour, Paul.
Yes. But, you know, the important thing is I know I was having a flashback there when you were talking about, you know, the vastness of SolidWorks and how people get into it and they start doing something and it's completely messing them up because they're not following the correct steps. I remember that was exactly the issue that we had in the 1990s before there was YouTube and videos on how to do things in coding and programming, and when I was teaching computer science. And the programs were so big that I think I'm doing it right, but it might have been just junk because you had no way of knowing, right?
Well, that's just it. I mean, could you imagine trying to learn how to drive a car if you just sat in it for the first time? You got 3 pedals. Well, which left foot goes on one pedal, the right foot goes on the other pedal, you know, and you sort of develop all these bad habits. So, but amazing program. It's a great resource. It's a wonderful way of sharing ideas too. And the beautiful thing is, with all this free software that SolidWorks is providing for us, we can be designing our robots anytime at all. We don't have to wait for the build season.
Right, and that's one of the things I think that's important about groups like Symbotics, for example, Team 1114 out of St. Catharines, is that they will provide you with design. So once they've built their robot, they post. I'm not sure if it's in season or after the season, but they do post their designs, and you can go and look at them, and they will help you if you contact them. They run a 24/7 help desk for First Canada. So if you contact them, they will get back to you, and they're super generous, as most FRC teams are. But certainly,
absolutely,
even if you're a rookie team and you're not thinking, oh yeah, we're going to design, still learn it. Learn it, yep. Because you can spend the off season working on that and getting help from people who are not going crazy trying to build their own robot, and certainly be better prepared for your second season than perhaps you were for your first. And it's all about increments, taking baby steps to make a robot and to make a team, right?
Right on, absolutely.
And I guess I don't know that people realize how fortunate they are with all the software that's provided, because SolidWorks is not the only design software that's available. There are other ones available for sure.
Oh, and Paul, you know, SolidWorks costs you tens of thousands of dollars a year to subscribe to it if you're a professional.
So it's a great free thing. It's a great thing for students. It's a great thing for teams. Not the mentors can't know everything. So
yeah, and it looks great on your resume.
Oh, absolutely. You mentioned simulations off the top. One of the things that's available that's being pushed this year is a product from Autodesk that's free called Synthesis, where it simulates the field, and you can create a robot in a 3D design program and then import it in there and run it around. So, and actually bring more than one machine, one robot, and actually compete. So that's
incredible.
Good. Oh, here we have our question from a mentor in North York, and he asks, SolidWorks versus Fusion 360, which should I choose?
Oh my gosh. That's kind of like a Ford versus GM question right there. Both of them have their strengths and weaknesses, and I would choose the one that you have the most support around you. If your company uses SolidWorks, if you have most of your students use SolidWorks, use SolidWorks. Or you know, Fusion 360 might be the other direction you want to choose. But perhaps if you have no predefined affiliation to either one of them, have a look at the resources that are available on each one of those, and gauge to yourself which one you think you could learn best based on the resources that are handy for you.
I think that's a common question for a lot of things. That's one of the ones we get about coding, and because there are 3 supported programming languages to code your robot, C++, Java, and LabVIEW. And one of the things that I've always told teams that are starting out is, it doesn't matter which one you do, you're going to have some problems along the way during the course of your season. So you want to make sure that you have somebody or some team or some industry mentor that can help you, because you're going to have some issues. So a team I was with did LabVIEW because they had a sponsor who worked in mechatronics and worked closely with National Instruments, the company that produces LabVIEW. So they were a resource for us. Some schools are saying, well, we teach Java. So, well, then it makes sense to program in Java. So yep. That would be, if you're at a school that does 3D design as part of their tech program, you might want to ask which one they use. I know, again, a team I was with, they used PTC Creo because the mentor knew that and taught that in class. So it made all the world of sense for them to do that. So that's a really good question, Alan, for sure. Anyways, I think, as you mentioned, Craig, I think we're done for today. I can't tell you how excited I was to see your email last week saying I would love to be a part of this. I know I've said many times on the webinars that if someone has an interest in being involved in the webinars, I would be happy to have you. It'll have to wait until we get to the kickoff. As it says there, there's no webinar. The first one we have coming back will be after the challenges have been released and the build has started. So we'll have some people talking about that and what they see, and some veterans, and see how they see the game that comes out. And we're all, like I said earlier, enthusiastic about seeing what is going to happen. As I mentioned at the start, the video, the webinar by Craig Maynard has been recorded, or is being recorded, and it'll be posted on the First Canada YouTube channel, and links will be put on the First Canada Facebook page so that you know. But if you're in doubt, if you have any questions, if you want to see even more, and I think one of the things we'll definitely want to send out, Craig, is the slideshow so people can access those links. Please contact me at pkeenan@firstinspires.org, or you saw Craig's at the beginning, cmaynard@firstinspires.org, and we will definitely get back to you with that information. And I'm going to call it, Craig. This is it.
You're calling it.
We're done for 2018. So
Wow.
thanks to everybody that's been on and listening and watching on YouTube. We've gotten a lot of people watching the videos after they've been posted. So that's good to hear. It makes it feel like it's been worthwhile for sure. And we wish everybody the best for the holiday season, certainly. And good luck and a happy build season in the last year of Bag and Tag, Stop Build Day. So good luck with that.
Thanks for that, Paul.
Thank you and good night.
Night.